I'm going to have a laptop. Somebody's going to be sitting here just to kind of keep it away from the water. A little bit different than the other oil filled one. We're not actually taking the data and saving it. We're just using it as an output because we have digital measurements, and then you're just copying that into your data table. The only things you're going to be taking off of the system is going to be the flow rate and then the differential head. Okay. I think it's in head. Yeah, 10 meters. The software, you may need to adjust it for the piping diameter that we're using, and then the temperature. So we'll just pick whatever temperature is for the day, and then as you use it, you can as you pick a different piping diameter, you can input that on the system too. But we're really just taking the flow rate and the differential head measurement off the system. So somebody's job will be to sit here and look at it. So our basic objectives for our fluid friction lab, we want to look at the relationship between flow rate and that pressure drop through the system, specifically through these sections. This is a 1 meter section of piping. Okay. You want to determine friction values for different flow conditions, and then we're going to look at the effects of pipe diameter and the surface roughness as well. So most of our pipes are smooth, but we do have one artificially roughened pipe. Okay. So everything with the last one is smooth, and this last one is rough. They do say what it is, and they do list the ID on them, in case you forget. Okay. We're not using all of them. We are skipping the 10.9 millimeter. That's just for time. Okay. We're also not doing duplicates. We're doing singles. So we're going to have 15 measurements per pipe, 4 pipes, so 60. As I mentioned earlier, we have to figure out beforehand what those flow rates are going to be. So we're trying to target some laminar, transient, and turbulent flow regimes for each of those. So split those up, those 15 runs up into those sections, and based on the diameter, you can tell us the different flow rates, right? So if you want the laminar, give us 5 flow rates in the laminar based on those piping diameters and water as a system, okay? I'll give you a hint. Sometimes it's not possible because there are a few stipulations I'll talk about. Sometimes it's not possible. That's okay. Just split the rest of them up. Okay. So the first thing we want to do is we need to make sure that we have enough water in the reservoir. Okay. The bottom of this thing is basically kind of starts color changing here. We want to make sure it's full of water up to here. Okay. I'll probably help you with that. We may move this over to the end and use the hose to fill it up. But make sure it's full of water. Whenever we plug it up, we can test the ground fault circuit interrupter. There's a way to test it just to make sure it's working. I'll probably help you with that too. So we fill it up, we test it, and then we need to connect it to the actual system. So we need to take this and lift it up and make sure this is actually inside. This is where the water is going to return back to the system. This is where the water enters from the outlet of the pump. So we'll just take this and we'll connect it over here. We'll plug it up. The pump switch to turn it on is over here, and you can adjust it with this valve here. So the submersible pump on the inside draws water from the reservoir, pumps it up this way, control it with the valve, and it enters the system over here. Okay, comes down and it can enter all these pipes. All right, and we'll open and close one of these valves depending on whatever one we want to use. Okay, so if you want to use the 4.5 millimeter ID pipe, close everything else and just leave this one open. Okay, pretty simple. There's a bunch of different pressure taps. There's all kinds of things we could do with this system, but we're just sticking to the pressure drop from the 1 meter spots. Just make sure that you put your pressure sensors inside. As you move them, you can just push down this little silver cord and click them and stick them in another one. Push through the plates. It's super simple to use, okay? Make sure the red one, have it taped off. The red one also runs back to the red side on the data output. So just make sure you do that one on the left. Before we start though, we want to kind of prime the system. By that I mean just get all the air out. So close all the valves except for the bottom one. This is when we're first turning it on. When you pump water through, allow water to go all the way through, out the silver side into the reservoir. You shouldn't see any more bubbles. Leave it open, open the next one, then the next one, all the way up to the top. That'll slowly work all the bubbles out. Once we do that, close everything but the one you want to use. It's pretty simple. This is a really easy one to use. You shouldn't see any bubbles in here. It should just be a clear section of water all the way through. This is our flow meter. All that data will output again back to the computer. I'll have my laptop plugged in, and so you can just read all the data off of it. Now, there are some limits to those sensors. There is a lower limit to the pressure that we can read, and then the flow rate that we can read. Fortunately, we do have another method to read flow rates, but we don't have one for the pressure. So this one's kind of limited. So it limits some of the measurements that we can take for the flow rate. We will use a graduated cylinder and a stopwatch for the really, really low flow rates. Once we fall beneath, I think it's 0.02 liters per minute. Liters per second. So if we have to take a flow rate less than 0.02 liters per second, we're going to be doing it with a graduated cylinder and stopwatch. That's probably going to be like a trickle of water out. So let's say we calculated for the pre-lab, I don't know, whatever number. We may not be able to get that exact number, but if you get one close to it, just mark it as 1 to 15. Okay, so the point of the pre-lab is just so you can provide us with a range to start with. And if you get 15 close to those numbers, just use them. As long as they're in the same regime, laminar, transient, or turbulent, it's fine. Okay. Now just give me a heads up, that may be the case. We are for the 17.2, so these are the big ones. We are, let's see what I said. We cannot use a flow rate less than 0.03. And that's because at that point, this drops below the sensitivity of the pressure sensors. Anything lower than that, so this isn't super accurate. And I don't have a small pressure manometer. That normally you can buy one of those and you wouldn't have a problem either way, but we don't have one. So you can't do any flow rates less than that while using these meters. So take that into account when you do your pre-calculations. For the 17.2, the big pipes, no flow rates less than 0.03 liters per second. Okay. Let's see. You hit it with your head or your hand?
My hand.
Okay.
I wouldn't raise my hand.
Yeah, question.
Is it, in case we forget that value, is that one procedure somewhere?
Yeah, actually, those are. That's what I'm reading off of, yeah.
It's all
Yep. It says, yeah,
You're supposed to read that before you walk into the lab for the cycle.
that's true. It's a good way to prep.
just want to ask questions, be informative, try to get a little dialogue here.
Well, let's go over it real quick, just to make sure we do have everything in.
That's a good idea.
So we have all four we're using. We have 15 readings, that's in there. We have manual readings using graduated cylinder for less than 0.02 liters per second. Anything else you can read off the software. 17.2 millimeter smooth pipe is restricted to, it says rates above 0.03 liters per second. Yeah, total of 60. We're always using the tappings that are 1 meter apart on the straight sections. It's always on the straight sections. We're not doing. You can do pipe size expansions too. Like you can use this and this to get what happens to the pressure losses with expansions, contractions, all those things. We're not doing those. We would have enough time. That's pretty much it. We already have the IDs. If you want to see what a rough pipe looks like, you can pop them off. Basically, somebody glued a bunch of sand on the inside, made it artificially rough. But by comparing this to the smooth, which you can just look up the smoothness for stainless steel. And the example of a sketch, don't put the exact one. If you want to take a picture down as a guidance, you can. Okay. Again, they're all labeled for the sizes and all that. We're using the gate valve, not the globe valve, and you're gonna have this all the way open. We don't want it to influence anything. Okay. You can adjust these to like force a certain system pressure, but we're not gonna get into all that. We'll just see whatever it is with it wide open. So I'd rather mention that too. If you don't have this open, obviously not gonna get any flow whatsoever. Make points. Okay. When we start getting the high flow rates, that thing splashes quite a bit. So just be careful. Safety stuff. Not a whole lot going on. So I'm not forgetting anything. Mostly just spilling water, and honestly, the biggest thing is tripping over these cards. I'm gonna try to pull them over and tape them, manage the spacing just so it makes it a little bit easier. But normally I'll have the wires this way, and I'll just have the person with the laptop sitting behind it, so you don't have to worry about crossing it. And it keeps it away from the splash zone. The other thing is just making sure that we test the ground fault circuit before we start, in case we do splash on it and get it wet. And then making sure the tank's just full, so we have enough water in. But since we're recycling, we shouldn't have to fill it too much, unless there's spilling water everywhere. But I doubt it. It's not that bad. That's pretty much it. So it's not a whole lot. Questions? Pretty much the hardest part is going to be getting those low flow rates. And it might take a while because you have to take a measurement. Too little, too big, and you have to keep repeating the process. Normally, the students will get the hang of it about halfway in. But anyway, that's about it. We got 4 pipes. Bring us 60 flow rates that you want to try.